All right, guys, this is it. Last new unit, last new entry of the year. There it is. We're doing pH and concentration of acids and bases. So combining last unit with this unit, and this is it. This is your last new thing of the year. So review pH scale. Remember, pH scale is a reflection of how acidic or basic something is based off of concentration and molarity of two ions, H plus and OH minus. H plus means acid, OH minus means base. But in the reality, um, even at pH 14, there's a really small amount of H plus, and we'll see that later. Even at pH really close to 0, a really small amount of OH minus, and they increase opposite directions. At pH 7, they're equal. So that's kind of a basic idea. So see, based off of last week, if you remember the answer to these three questions. So just pause for a second if you need to. Concentration of H plus is highest at 0. Concentration of OH minus is highest at 14. And they are equal at pH of 7. Sorry, at pH of 7. Okay, one more review. Is pH of 11 more acidic than 13? Yes, even though they're both on the basic side, 11 is lower than 13, so it's more acidic. True or false? Is pH of 4 more basic than 1? Yep, even though they're both acidic, again, since it's closer towards the base side, it's more basic. What's the change in concentration from 11 to 13 and 1 to 4? Remember, every change in one number is 10. So 11 to 13 would be 10 times 10. It's 100. And 1 to 4 would be a change of three numbers, so 10 times 10 times 10, which would be 1,000 based off of this. So that's a review. Now here's your new stuff. Remember, the brackets means the concentration and molarity of whatever's inside. For us, it's going to be H plus and OH minus. And then here we got strong acid, weak acid. The red is the H part. So notice that the H separates when it goes into water. It completely dissociates. That's called a strong acid. Sometimes it doesn't separate, sometimes it does, and a weak acid. We'll come back to that later. But in general, when it's put in water, since it separates, that's concentration and molarity. So remember, the property of an acid is when you put them in water, they separate, right? So we get this H plus ion, and that is directly related to pH. So H plus is the concentration of hydronium ion. That's the brackets part. Remember, H plus and H3O plus mean the same thing. And now the number this number tells us how many moles of H plus there are in a liter of solution. When I have a higher number of H plus, it's more acidic. So let's look over here at this chart here. So 10 to the negative 7 is pure water. That's a concentration. That's a number. 10 to the 0th power means 1. So if my concentration molarity, 1 molar, its pH is 0. Okay, I can actually get a negative pH because if I had an acid with a concentration of, let's say, like 3 molar, it's going to be more concentrated than that. So realize that right here we have this spectrum of concentration. And these are pretty small numbers. Okay, they're pretty small numbers. And then you have a lot of different solutions. So even these bases like household bleach has a really small amount of H plus in it. It has a tremendous amount of OH minus, which we'll come back to later. Now, as you can see, pH is directly related to concentration of H plus. And actually, pH is equal to negative log of the concentration of H plus. So if I take the negative log of 10 to the 0, or 1, I get 0. If I take the negative log of 10 to the negative 1, I get 1. Take negative log and so forth and so forth. Now concentration of H plus is just the opposite. 10 to the negative pH, so 10 to the negative 6 is going to give me the concentration of the H plus ion. Now this is something you have to calculate because you can't have exponents with decimals. So I'll show you how to do that a little bit later. But in general, all you do is in your calculator plug in 10 exponent, negative, whatever that number is, and it'll punch out your answer. So pH means power of hydrogen. It's a measure of how acidic or basic something is based off of H plus. And bases are the opposite. Remember, when you put a base in water, OH minus is what is created. So when I put an OH minus in water, I get the hydroxide ion. I'm measuring the concentration of that. Tells us how many moles of OH. Again, when I look at my pH scale, it goes from 0 to 14. At 7, we have this dividing line where the concentration of H plus or H0 plus is the same as OH minus, and I get more acidic or basic. But if you look at this one is really unique for a couple of reasons, because it shows me the direct relationship between POH and OH minus, and so forth, but also pH and H plus. But here, this triangle is really useful because it shows you amounts. Over here, it's like all H plus and almost no OH minus. Over here, almost no H plus and almost all OH minus. And that's what you get here. The total amount almost is like the same here, but you get this spectrum of H plus and OH minus. So when I get a higher amount of OH minus, when I'm moving this way, notice the chunk of the triangle gets bigger. It is more basic. When I move it this way, it's more acidic because my H plus is going up and my OH minus is going down. But all this is related to moles per liter. We'll see some practical examples here in a minute. Now the last part here is POH, and this is the opposite of pH. It's the power of hydroxide instead of hydrogen, so it's a scale based off of the concentration of OH minus. So we have 3 more equations here. First, pH is 14 minus POH. Notice if my POH is 14, 14 minus 14 gives me 0. There's pH, and so forth. POH is negative log of OH minus, and OH minus is equal to 10 to the negative pH. Sorry, that should say POH. Let me fix that quick. Okay, so this color is based off of indicators. I'm not going to talk about that a whole lot, but this is a really nice thing for you to look at, because realize that 10 to the negative 14 is a really small number. 10 to the 0 is a pretty big number, relatively speaking. That's 1.000000000000001. A really small number, and so forth. Okay, at 7, OH minus and H plus are the same, 10 to the negative 7, and POH and pH are the same. So neutral, everything's about 7s. And this is a helpful thing for you to realize. Remember, one thing we talked about last week was, hey, is H plus higher than OH minus? Well, 10 to the negative 2 is bigger than 10 to the negative 12. So based off of exponent alone, I can say that H plus is larger than OH minus is an acid. Okay, so there'll be a couple questions related to that. All right, so this is another thing for you to see the relationship between OH minus and H plus and pH. So as I move this way, as my concentration of OH minus increases, look how small that number is compared to 1. As that gets bigger, I get more basic, higher pH. As I would move that way with H plus, the number gets smaller and smaller and smaller, so I'm getting more basic. But if I go this way, pH towards 0, my acidity increases concentration in moles per liter. So this is another helpful thing for you to realize, like 10 to the negative 14 is 0.0000 and so forth, 1. And 10 to the 0th power is 1. Okay. So let's look at some practical questions. So the first one is, what's the concentration of H plus if I have an acid with a concentration of 0.2 molar HCl? Realize this is like what we did last unit with concentrations. Well, remember, when I put HCl into water, it separates into H and Cl. So my concentration of H plus is just 0.2 molar, okay? Because that's the concentration of that solution. There's 0.2 moles of H plus in that solution. There's 0.02 moles of Cl in that solution. So my concentration of H plus is 0.2 molar. The pH then is just negative log of that number. So I put negative log of 0.02, I get 1.69. 2 ways to calculate here. If you use an iPhone, there's a log on there, but the way you hit the buttons is weird. You type in 0.02, then you have to turn it sideways, so horizontal, and hit a button that says log 10. So that's what this log is log 10. It's just not always written with that base because you can technically change that number, but that's a ton of math beyond us. If you hit the log number, it works. Then you hit your negative sign. So when I put 0.02 log, it'll get negative 1.69. Then I got to hit the negative sign to get positive 1.69. On a calculator, I can just plug in negative, not minus, not the minus sign, negative log 0.02, and I will get the same number. Let's look at another practical question. What's the concentration of H plus in a solution of 0.2 molar H2S? So what's different about this one compared to this one? Well, here it's HCl, here it's H2S. Notice I have two H's. So instead of being 0.2, I got to multiply it by 2 to get 0.04. It's because I doubled my H plus. So then to find pH again, I just hit negative log of 0.04. I'd get 1.40. Notice this is more acidic than the other one. Because there's two H's, there's more H's available, more acidic, lower pH. So again, calculating it would be the same way. Either iPhone 0.04 log negative or type it in a calculator. Calculator is the best way to do it. And I'll show you that on the homework walkthrough, which I'll put in this folder as well. So what's the concentration of H plus in a solution of 0.02 molar? Oh, hold on. So I got turned around there for a second. So similarly, if I have a base, what do? What's the concentration of OH minus? Just like before, since I have the concentration of a base here, the concentration of OH minus is going to be 0.02 because I got one OH here. What's the POH? Same thing. Negative log of 0.02, I get 1.69. But here's the idea, is that POH is not how we typically think of acids and bases. We typically think of pH. So remember, pH is equal to pH is equal to 14 minus POH. Because if I look at this number, a POH of 1.69, a lot of people think acid. But since I have pH is 14 minus POH, I'll be able to say that pH is 12.31. Is that an acid or a base? If my pH is 12.31, is that an acid or a base? That's a base, right? So what's the only difference if I have the same thing here? So this concentration of OH minus here. Since I got OH2, I just, like before, double it. So I get 0.04 molar. What's the POH? Negative log of that number gives me negative log of, that should be 0.04. 0.04 gives me 1.4. But remember, if I want the pH, it's just 14 minus POH. So I get 14 minus 1.4 gives me 12.6. Okay. So there's some practical questions. One last thing here is the difference between strong versus weak acids and bases. A lot of times your teacher may have told you in the past it's based off of pH, right? A pH of 6 is a weak acid. Not true. It's about dissociation. If I see a double-sided arrow, that's a weak acid or base. Since it's OH minus, that's a weak base. Since I have a single-sided arrow here, that tells me that it always separates. That is a strong acid or base. Okay, so if I look at these, I'm looking at the arrow. Single-sided, double-sided, double-sided, single-sided. Does it always separate? Yep. Is it an acid or a base? Acid. So that's a strong acid. Here, does it always separate? No. Sometimes it does, sometimes it doesn't. Is that an acid or base? That's a base. So that's a weak base. Here, does it always separate? No. Is that an acid or a base? Acid. It's a weak acid. KOH always separates. That's a base. It's a strong base. Okay. And that is the basis for what we're going on to here. Okay, now after this, there's some problems to try. I know this is a long note, so if you just want to try these later this week, go for it before the quiz. But that's leading in here to the next problems, but I'll walk through that on Thursday. All right, guys, love you. Have a great week. And if you want to try the homework now, go for it, and the quiz for Friday. Bye.